Kia ora, Year 11 and 12. Here's the first excellence question from last year's 2018 calc paper. And it's the easiest excellence question ever if you've got the hang of it. And it goes like this. We're asked to show or to find the values of x for which the graph of the following function is increasing. And again, what we did in level 2 graphing this year is really going to help us. So if we think about that function, even before we start differentiating, we've got a cubic. And it's a positive cubic, right? So the shape of that graph is going to be this. Whoosh. What does it mean for a function to be increasing? Well, it's just what you might have a guess at. It means basically that we're going up the hill when we move in this direction. So we want to find where the gradient is positive. And you can see on the graph that there are going to be two places where that happens. There's going to be from here up to here, and then there's going to be from here onwards. So our answer in this case should end up having two sections of the graph. So it'll be x less than something, and then it'll be x greater than something. And we have to figure out what those numbers are. But we need to do some pretty good communication in this question. So we're going to say what it means for a function to be increasing. So let's write that down. So for a function, fn, the function, to be increasing, we need, or we require, the gradient, f dash of x, to be greater than 0. Now you can get into good discussions about whether you mean greater than 0 or greater than or equal to 0. The marking schedules put it like this, and that's fine. So we call that, when you're doing more maths, you'll call that strictly increasing. In other words, it's not going to include the value here and here. Right? But that's a pretty minor thing in the scheme of this question. So what we're going to do now is we're going to find the gradient function. I'm really sorry about the background noise, guys, but I can't ask my daughter to be quiet in the holidays. She just won't do it. So I'm just going to have a bit of violin music. So here's f of x, and f of x is 2/3 of x cubed plus 9 over 2 x squared minus 5x minus 18. Right, so the first thing to do is to differentiate it. And we're going to get f dash of x. I'm going to do this quite slowly, because I know some of you watching are just starting out with differentiating. Others of you will be watching this in desperation near the end of your exam. Good luck with that. Right, so there's my gradient function. So it's 2x squared plus 9x minus 5. And now we have to solve this greater than 0. So we call that a quadratic inequality. We're lucky though, because this function here is pretty easy to factorize. It factorizes to 2x minus 1 times x plus 5, strictly greater than 0. Okay, so in here we can get two critical values that will make this equal to 0, and they are x is equal to 1/2 or x is equal to -5. But what we want to do now is to go back to that first picture and go a bit better than that. We want to say, well, this first bit of where it's increasing is when x is less than -5, and the second one is where x is greater than 1/2. Okay, so let's go and do that now properly at the bottom. So what do I have to do here? Well, the best way to do this is to draw this parabola. Right, and this should be really easy now. We've got a root here at -5, and we've got another one at 1/2. So when I draw this, what I'm looking for is when is this function positive. And it's positive here, and it's positive here. So my final answer is x, whoops, wrong pen, x is less than -5, or x is greater than 1/2. There you go. So a big T code if you got all the way through with that. Thanks for watching. I will be back when my daughter's finished her violin practice, because it's really hard to concentrate on maths with that in the background. So sorry about that. More from me later on this evening.